Hey YouTubers, it's Jeffrey here. This segment is going to be on the polygons again. These are the polygon shapes that you find all over Mars, all over any planets really, Earth, Pluto. And I had done a previous video on the same subject, and I probably should have added this in because what I'm going to talk about today is these polygonal shapes, also called periglacial polygons, which is really, they're talking about permafrost, the action of permafrost. And in this video we searched this entire photo with the polygons. There they are. These are actually in a young state, but I think what happened is the water dried up before they really had a chance to become something like this. We also covered the crater on the same photo that was alleged by our favorite illusionist that there were buildings all over the place, structures, whatever. Anyway, there's the crater, nothing there. And we searched all over the whole photo and did not find that there were any buildings there. So, this photo though, this video and this photo, is what happens to these polygons when all the moisture disappears and they shrink. And if you first look at this, it's almost an optical illusion because it looks like these are all bulged up in the middle, but actually they're not anymore. In fact, they're quite depressed, and the centers of these things have subsided quite a lot. I always have to come down here and look at the walls first and then come back out. Now it looks like they're depressed because it really depends. It's almost an optical illusion. But my main point here is on these is that, let me get this magnified up here just a little bit so we can see what's going on here. Now the spaces that are in between these polygons originally, and let me see, I'll pull this one up here. Now this is what they look like in the height of their process. And this is all permafrost under here. This is the action from permafrost. And we have the centers of these things are all bulged up. Any material that is welled up from the inside of these polygons down low, and this permafrost can be 40, 50, 60 meters thick. It's very thick. And all the debris falls into these little cracks here. They call them ice wedges. And this is the ground heaving up in the middle. As you can see in this photo, where the rocks have come up from the center, from the action of the permafrost, lifting the rocks from below and bringing them up, and then they roll off to the side. Well, these aren't really raised that much anymore, and I think they're pretty much inactive. I call them dead polygons because that's what they are. The process is no longer really taking place, and on some of the bigger ones you get this. I like this picture here better. Like I said, I always have to zoom in down on the bottom and then come out. But let me go in a little more here on this. Now we can move around and see that these are walls, especially like this part down here. This is a pretty tall wall, and this is the debris that fell into the ice wedges around the edges of these polygons when they were forming. All the moisture is gone, and by moisture I mean water ice that is below the surface, and also the carbon dioxide ice. Carbon dioxide goes from gaseous state to solid state with no liquid in between, whereas the water does have a water state, and we have a lot of expansion and contraction going on there. Here is the atmosphere of Mars, almost all CO2, so they must have a real global warming problem there. But not really. Mars is a little farther away from Earth. It's a lot smaller, so if you're planning on moving to Mars, I don't know. It really doesn't look like the place you'd want to be if you compare it to the way Earth looks. The temperatures on Mars are not that bad. During the day it may get up to 80, 90, even 100 sometimes. But it's at night that's the worst. It gets really cold at night, and we're talking minus 100 degrees. Here's the chart. I think these are days down here on the bottom. Winter, summer. So at least during the summer you do get up here to, on the Fahrenheit scale on the right here, it looks like it's almost 100. But at night it's horribly cold, probably around up to a minus 150. Well, actually it's minus 120 in some cases. There's lots of these different charts. If you do a start page search and just click on the images button above, you get all of this, and you can find out everything you want to know about the temperature on Mars. Here's just a few quick facts about Mars compared to Earth. Very similar in a lot of ways. The orbit of Mars is about twice as slow, I'll say about half the speed of the Earth as it goes around the Sun. So their year is actually almost 2 of our years. Here's another chart showing the temperature data for Gale Crater. So all those temperatures are pretty much in line with what I just said. Here are the gases in Earth's atmosphere. A lot of nitrogen, a lot of oxygen, and Pluto, by the way, is almost all nitrogen. And they have nitrogen ice on Pluto. On Mars we have carbon dioxide ice. It actually gets so cold that the carbon dioxide, which is 95% of the atmosphere, freezes, and it actually forms a snow on the ground. But it doesn't actually melt, it just evaporates when it warms up a little bit. So we have these high walls that form in between the polygons. And these walls are really high. I can bring this, let me bring that magnification up just a bit here. Down on this wall here, this is a very high wall. You can tell by the outline, and this is magnified a little bit here. It's amplified by the fact that this is actually sloping down. You can see the sand dunes all over in the middle. And what happens with these walls, how they're formed, is all these rocks and debris roll down the sides into these areas here. But it's not just rocks and boulders, it's sand, dirt, whatever, dust. And over time, this sand and dust glues the rocks together, more or less, and then you end up with a conglomerate. So these walls are actually just piles of rocks that were formed into the wedges. This all shrinks in the middle, subsides, which gives you an idea just how much water moisture and carbon dioxide ice was there to begin with. That's a lot. That's a lot of moisture to just disappear. So you end up with this baked clay mud look. Now some of these polygons don't really have that much debris in here, and they'll, when they're inactive, they look like this, but they just don't have these high walls. Now, some of our favorite illusionist researchers would like to call those intelligently built, with buildings and structures. And if you look at this, you can see those little bumps on there. Well, that does look kind of suspicious, but it doesn't mean it's anything but boulders. And some of these there, you can see where they really piled up over here. These are spectacular walls. These are supposedly anywhere from 40 to 60, 70 meters high. So those are pretty high. Now, anybody that says that these are walls made by whoever must not be thinking too straight, because this is a permafrost area. No one would want to live there because of the action of the ground and the permafrost constantly moving. And why would you keep walling yourself out, you know? I mean, what's with the, we just wouldn't do that. So I want to dispel any ideas that these are alien-made, man-made, or whatever. Okay, so here's an example of extreme periglacial process. There's not many stones here. It's probably mostly sand, clay, mud, and there's probably a lot of carbon dioxide ice here along with the water ice. So you get this, and this is very similar to some of the formations found on Pluto. The only difference being that Pluto is almost all nitrogen, so you will get solid nitrogen ice. It forms the same process. Forms these polygons there on Pluto and every other planet, including Earth. Here's another example, a bizarre example of polygons. Now these don't look like the other polygons, but all those lines are actually just dust forming between the areas where the permafrost is creating these polygons and separating this out into what you see as lines, but that's really just dust. There's another picture of it. More polygons, only this is a different type of polygon. Not so much the upwelling. So that concludes this quick video here on that. It's always good to know what the geologic process of these things is. It helps you understand more about the permafrost process that takes place on Mars and other planets. And I hope that clears up any doubt that anyone might have about where these things came from and how they got there. This also adds fuel to the theory that I have that Mars is actually drying up still. It's a continuing process. It looks like it's just never going to end until all the moisture is gone. I don't know where it's going, but Mars has a very thin atmosphere, and I have a feeling that a lot of this is just evaporating out into space. So the water is there. It's locked up underneath, and it's locked up in the North Pole area and down towards the equator underground. But it really does look like it's dwindling. So if you're planning on going to Mars, I would think twice about that. So, have a great day. We'll see you in the next video.